Evaporation, it consists of two words, evaporation and transpiration. Evaporation is evaporating into the air of soil-water content. Transpiration is transpiring, but then of plants. So that's what evapotranspiration is. And I'll use the word a lot in my presentation, but I'm not sure if I continuously say evapotranspiration because it's quite a difficult word. But yeah. So that's what I study on a very small scale, on a plant scale. Our group in Wageningen studies the lower part of the atmosphere, and I mainly focus on this plant scale, the exchange of moisture, of heat, CO2, and those things. And today I hope to convince you that it's very important to study those things on this small scale, and I'll give you an example of how we contribute to this knowledge. So. To start with, we all would like to keep our wetlands in nature wet. We would like to grow a lot of crops all over the world to feed the whole planet population. We would like to have good forecasts for climate change. We need certain laws for dry areas for maximum irrigation rates. So we need a lot of environmental models. But the problem is, those models are all based on evapotranspiration, and this is an input value that's very hard to estimate. Of course, certain things are already existing about estimating evapotranspiration. Currently, a lot of models use data from satellites, but satellites don't measure directly evapotranspiration. They derive it from temperature, radiation, and other things, so there's a lot of uncertainty in the data. And also, if there are clouds, you don't have even measurements. And the satellite data is based on kilometer scales, while if you want to put plant processes in your model, you need very small scale processes, not one evapotranspiration value of a kilometer grid box. So that's why I study those things, and I hope I can give a solution for this. In our group, we have instruments that measure evapotranspiration. On a bit larger scale. They measure at one point above the surface, and the source area where it really evaporates and comes at the point in the air where you measure is located upwind from the instrument. So the source area differs with wind direction. So if you want to measure one crop type, you need a very large field, and you need to be in the middle of it. But at a lot of places in the world, you have land use type differences that differ on a very, very small scale. So you need better instruments. And that's what we developed together with a German institute. We developed this box. We call it a large chamber, and it's a box with a lid. As you can see, it has some special foil on top of it, which is transparent for UV and visible light, so that it doesn't stop photosynthesis, because then your transpiration won't be valid anymore. How it works, it's a box with two open sides, and you place it that the wind can go through it. So you place it in the wind direction, so you have to maybe replace it a couple of times per day. But then when you have your setting set very well, you place the lid on the height of the vegetation. Then you can measure the water vapor concentration at the inlet of the air and at the outlet, and you know that the increase in water vapor concentration is all due to the soil moisture and the plant transpiration. So you can derive evapotranspiration at this scale. I forgot to tell you, but there's also instruments that measure evapotranspiration really at one plant. But if you try to get a value for a field of a lot of crops, one plant is not enough. You need to do a lot of repetitions. And in this way, you get a representative value for a whole field. Because we tested this on very large fields, where we also had this previously mentioned instrument, which works on very large fields. And our measurements, our evapotranspiration measurements, agreed very well with this larger scale instrument. So this is a new measurement tool to measure evapotranspiration, and I think it's a good example to show that we work on quite some good stuff in our group, and I hope in the end it will make a bit more fair and efficient decisions for policymakers on a lot of environmental issues. Thanks.